present this challenge for everybody. Um, Aqua Power, I'm working in Aqua Power Innovation Department, leading the energy storage technologies, and a little bit of background about Aqua Power. Aqua Power is a Saudi-listed developer, owner, and operator of water desalination and power generation plants with around 10 million cubic meters per day of desalinated water produced, around 80 gigawatts of power generation. More than half of it is renewables, technologies such as PV, wind, CSP, and so on. The other half of it is conventional power generation, mostly CCGT. And in addition to that, we are very involved in energy storage, more particularly in battery energy storage. We do have a few gigawatt hours in our pipeline, and we are expecting to see more in the near future. We operate in the Middle East, in Africa, in a lot of countries in Central Asia, in Southeast Asia as well. All right, so we have a good fingerprint in the worldwide. So now, when it comes to energy storage, we use, as I said before, we do have a few gigawatt hours, and we use lithium ion at the moment for our energy storage grid scale. Yeah, we're talking about grid scale, large scale, grid connected stationary energy storage systems. We're using lithium ion technology. Most of you are familiar with the challenges of lithium ion. We have to treat them like little babies, basically. We have to make sure they operate within acceptable temperature operating limits. We have to make sure they don't degrade too rapidly. We have to take care of them properly, right? So you'll see a lot of cooling systems in place. You'll see a lot of battery management in place. All these things, and getting down to the challenges and the problems and the issues that arise with using this technology. One very fundamental thing is the battery itself, right? It's an electrochemical battery cell, and we all know that energy involves a risk. It's just about how we manage this risk. So getting down to the fundamental component of the system, which is the electrochemical cell, we see a lot of variability between different cells in our systems. You have to operate them within acceptable voltage and temperature limits and thresholds, and so on. So some of them degrade faster than others. There's some variability from manufacturing stage already. This variability with time, it increases the gap between the different battery cells in terms of performance, the battery model itself, the coefficients, the components of the battery model, degradation, and so on. So with time, all these battery cells become very different compared to each other. So you have to pay close attention. This is one of the components that is causing a lot of problems in the system. The other components that are causing problems in the system are not the batteries, but the peripheral systems like the power conversion units, the battery management system itself, sensors, the monitoring system, detection systems, and so on. Ironically, sometimes even the fire suppression system is causing some issues, right? So for this particular challenge, we will not be focusing on the peripheral systems. We'll be focusing on monitoring the battery cells, the battery system only at this stage. Later on, we can add more. So, as I said before, some issues, some shutdowns can be caused by overheating or misconfigured controls, design flows, and so on. So you have to shut down your battery rack, or you have to shut down your entire container to do some maintenance, or you have to shut down the entire DC block or the AC block even to do some maintenance. So that causes a significant impact on availability, the available capacity we can use, and everything. Performance deviations across the different batteries, more particularly state of charge imbalances. As I said before, the different cells are not all exactly the same. From manufacturing stage, they come with small variations. These small variations in terms of resistance and so on causes imbalances in the state of charge, imbalances in the state of health, variability in temperature and the resistance and everything, causing some cells to underperform. And this, with time, again, as I said before, this gap keeps increasing. And you want to be able to monitor this and control it in some way. Safety issues, of course, because of some cells are degrading faster than others. Some cells, they experience higher temperature profiles than others. So this higher temperature or over voltages can lead to safety issues such as thermal runaway. This thermal runaway will lead to catastrophic results like increase of flammability risk and even explosions, right? So we want to be able to take care of these issues and be able to control it. Health, of course. As I said before, some cells are degrading faster than others. The state of health, we want to be able to estimate properly and to predict also, to know what's going to happen in the future, what is happening now, and what's going to happen in the future. And we want to be able to also do some, let's say, preventive and predictive maintenance, replace batteries on time in a timely manner to minimize our costs as well, and to avoid faster degradation of some cells and thermal runaways and all the safety issues that I discussed before. All these issues are being taken into account during design phase most of the times, although we do experience a lot of these issues also during operation. During design phase, these issues result in oversizing the system, which means we have to put more effort, more money in, more budget. Higher cost for balance of system, balance of plant, and so on, for detection systems, for sensors, for monitoring systems, for management systems, and so on. Later on, during operation, that also results in, all these issues result in high operation and maintenance costs and very frequent augmentation, which means the replacing of battery cells and battery modules every now and then to avoid all these issues, which is costing us money, of course. Yeah, we want to minimize all these things.
Christos,
Yep.
You're over time, and I don't think you've done your slides, although you've covered a lot that's on you've been talking, but the slides haven't advanced.
Yeah. I don't have many slides. I have only 2 slides left. So now, based on this, we're looking for a solution, a software-based solution, to be able to monitor these batteries, right? And their health, their performance, safety, and also be able to visualize all these things in a web platform or a local server or something like that. We want to be able to see also how our plant is doing, right? So we want you to design a software-based solution with analytics, with AI, with modeling, with whatever you think it is appropriate to be able to monitor and track the performance and the health and the safety of the battery systems, including detecting of faults, predictive and preventive maintenance, issuing of alerts, tracking of the warranties and the availability and the round trip efficiency of the battery system, monitoring the different parameters, the voltage, current, temperature, and so on, being able to estimate the state of the battery, the state of charge, state of health, and so on, and whatever else you can imagine, right? And you can find a lot of these, some of the criteria, some of the performance, the technical requirements in the website as well. We have a list of them. I have put this list there in my presentation, but I don't want to go through this now because time is running out. I just want to mention that we are not looking for a software solution only. I don't want to give you a 1, 2, 3, 4, 5, and then you do this 5. We're looking for battery knowledge, people with deep battery knowledge that can also advise us, that can also guide us through the process, and that who can build a comprehensive battery monitoring solution for us.
All right, you're nearly on
Thanks,
time,
Adam.
so no problem, Christos. You have been quite extensive, and as you said, there's other information on the website, but now's the time quickly for anyone, if they've got specific questions for Christos, if you haven't typed them in, I can't see any in there at the moment. I see your comment, Christine, thank you, but I don't see any specific queries of Christos at the moment. Just
if there's no questions, you can reach out to me on LinkedIn. You can find me on LinkedIn with my name, Christos Iraklis, or my email.
And ourselves will be providing the information at the end of the session so that anyone that's got follow-up questions, they can contact us at Padang.
Yes,
and
please.
as Christos says, direct you to the website where the details are. So why don't we, just in the interests of time for everyone, unless there's anyone for the last minute, going once, going twice, going 3 times.